Greetings, listeners. The South African Mathematics Foundation, abbreviated as SAMF, with website www.samf.ac.za, administers a number of mathematics competitions annually. Amongst them are the South African Mathematics Olympiad, as well as the South African Mathematics Team competitions. The Olympiad competitions comprise of 3 rounds each, junior and senior, while the team competitions have the junior and the senior, individual and the team. In this series, we will try to unpack the solutions to all these competitions, save the senior round 3 mathematics Olympiad papers. Today, we are going to do the South African Mathematics Olympiad paper, which was set in 2023. We will try to discuss the problems of 2023, 2024, and 2025. All right, so this is the senior round 2, 2023 paper that we shall be discussing. Those few words, let us go straight into the paper proper. Okay, so as you can see, it's Senior Round 2 Training Program 2023. Let's have a look at the very first question. All right, here we have a calculation. Well, the denominator is 7. So you have the fraction 2023 divided by 7, and that is 289, which is inside the square root. And the square root of 289 is 17. So that's the answer. Okay, let's get on to the next problem. I write down the solutions. The solutions of all the problems are typed in addition to this verbal presentation. So this is the solution, as you can see. Now let's get on to the next problem. The second problem is find the smallest positive integer by which 396 must be multiplied to make it a perfect cube. All right, we need to factorize 396. You will see, when you factorize it, you'll see it's 2 squared times 3 squared times 11. Now, to make it a cube, perfect cube, all indices or exponents, sometimes the indices are called exponents, are multiples of 3. So for a perfect cube, when you factorize it as a product of prime powers, this is a product of prime powers. You want these indices to be multiples of 3. And for the smallest, you want them to be as small as possible. Therefore, the one that we're looking for is 2 cubed, 3 cubed, and 11 cubed. Okay, so we have to multiply this to get to this. So all you have to do is to take 2 cubed, 3 cubed, 11 cubed, and divide it by 2 squared, 3 squared, and 11 to see what this number is, and you'll see it's 2 times 3 times 11 squared. Well, from here you can see it directly. You have to multiply this by 2 to get a cube. You have to multiply this by 3 to get a cube. And here you have to multiply this by 11 squared. That's what we've got here, 121. So that is 726. So the answer to this problem is 726. And that takes us to the next problem. And there you have it. This is the answer. Okay, we'll go on to problem number 3. So problem number 3 says simplify this expression. Okay, so when you're multiplying fractions, you have to convert them to proper fractions. So this is improper, 1.5. So that's the same as 3/2. 1 times 2 plus 1. 1 times 3 plus 1 is 4/3. 1 times 4 plus 1 is 5/4. So we first have to convert this to this form. And once you do that, then you cancel. Or if you divide throughout by common factors, you'll see that 3 cancels with 3, 4 cancels with 4, and we expect 5 to cancel with the next one, and 17 to cancel with the previous one. Okay, so in the end, the only survivors are 18 and 2. So the final answer is 18/2, which is 9. So this expression simplifies to that. Okay, so there you have it. This is the worked out solution. Let's go on to problem number 4. This problem says a monster has 5 heads. So this monster has 5 heads. Each time a head is chopped off, okay, so when you chop off a head from here, it now has 4 heads. 5 new heads grow. In other words, you start off with 5 heads, you chop off a head, right? And 5 new heads grow. In other words, you've got 4 new ones now. 1 head is chopped off. So after 1 head is chopped off, you've got 5 plus 4. And here, this is 1 head chopped off. And now 6 heads are chopped off 1 by 1. So in each case, as we had here, the number of new heads is 4. Because each time you chop 1 head, 5 new ones pop up. So the number of new heads is 4. So you got 9. And then this is 2 heads chopped off. You want to know how many heads will the monster have? Yeah, if 6 heads are chopped off. So let's just look at this. Each time you have 4 new ones. So you keep adding 4, and this is the third head is chopped off, fourth, fifth, sixth. So when the sixth head is chopped off, you have 29 heads. So how many heads would the monster have? The answer is 29. So you keep chopping off a head, 5 new ones grow, so the number of heads increase by 5 each time, starting from 5. Okay. So as you can see, this answer does say the answer is 29. So let's now go to problem number 25. If x plus y equals 1 and x squared minus x minus y is 3, what is the value of 2 to the power of x squared minus y squared? So let's just look at this exponent. And by now you should know that this is a difference of 2 squares, and it factorizes as x minus y into x plus y. Whenever you multiply two numbers, well, the difference of two numbers, it's the difference, and the sum of the two numbers, when you multiply these two things, you have the square of the difference. See? Like for instance, if I take 8 squared minus 5 squared, and this is, we already know this is 64 minus 25, and that gives you 39. But you could have done it like this. This is 8 minus 5, sorry, 8 minus 5 into 8 plus 5. And that is 3 times 13. And 3 times 13 is 39. Okay, yeah, I forgot for a moment that you are seniors, so there was no need for me to expand on this. But now this is 1 times 3, so this is 3. Substituting these two numbers, therefore, this is 2 to the power of 3, which is 8. Because x squared minus y squared is actually 3. Okay, so let's get on to the next problem. So as you can see, the answer is 8. We go on to problem number 6. The infinite geometric sequence, which begins with 50, 48, 46, and so on, contains only one odd integer. Well, this is 2 times by itself 50 times, so this is even. This is obviously even. So all these seem to be even. So what will be the odd integer? The odd integer will be 2 to the 0. That's 1, you see. That's the only odd integer. All the other ones are even. Okay, so we need to see when does this become 0. The odd integer is the nth term of the sequence. What's the value of n? So we need to work out the nth term of the sequence 50, 48, 46. Let's work out the nth term of the exponents is, now there is a formula for the nth term. This is an arithmetic sequence. Let's just make that as an observation. Which is an arithmetic sequence. This is in your syllabus. With the first term, A, is equal to 50. And there is a common difference. It's decreasing. So the common difference is actually D is minus 2. Because it's decreasing by. So all the common difference is any term minus the previous one. So 48 minus 50 is negative 2. Right? And we know the formula, the nth term for the sequence. There's a formula for it. It's a plus n minus 1d. So that's 50 plus n minus 1. This is the nth term, right? Times negative 2. And that gives you 52 minus 2n. So this is the nth exponent. You can see when n equals 1, you have 52 minus 2, and that's 50. N equals 2, you have 52 minus 4, that's 48. So for which value of n is this 0? We want the exponent to be 0. When 52 minus 2n equals 0, so 2n is equal to 52, and n is equal to 26. So the 26th term has got n. N represents the nth term, first term, second term. So the 26th term is what you're looking at. Answer, 26th term. All right, so that takes care of the problem number 6. So there it is. You can see that n is equal to 26. So let's go on to problem number 27. Problem 7, sorry. Okay, this is a geometric problem. Find the sum of the shaded angles. Okay, so there are 6 blue, 2, 2, 2. So you need to calculate the sum of all these angles. So how do you do that? Well, let's have a look at it. These 2 angles, for instance, they are 2 angles of a triangle, but the third angle is this one. Let's call that angle A. And these 2 are also 2 angles of a triangle, but the third angle is B. This one here. And likewise, these 2 are angles of a triangle, and the third angle is what I've indicated there. We're calling it C. Okay, so the angles of the small triangle are A, B, and C, and let S be the sum. Be the required sum. The question asks for the sum of the shaded angles. Now what I'm going to do is I'm going to add A, B, and C because I know that S is equal to, I'm going to put S plus A plus B plus C. I can't do that. That's not allowed. I have to subtract the same quantity to make this equation valid. Now we saw that this is, each time when you add A, you're getting the angles of a triangle. When you add B, you get the angles of another triangle. When you add C, you get the angles of another triangle. So this is 3 times 180, this part here. Because it gives you the angles of 3 triangles. But A plus B plus C are the angles of the inside triangle. So that's 180. The sum of the angles of a triangle, 180. So you got 3 180s minus 1 180 So that is two 180s. So 280 degrees is 360 degrees. So that is the solution to problem 7. Okay, so as you can see, it's 360 degrees. That takes us now to problem number 8. Problem number 8 says a watch is placed face up on a table so that its minute hand is northeast. So let me draw a watch. Okay, so the minute hand of this watch is facing northeast. So the minute hand shoots out from the center, it faces northeast. Now this is north here. And this is east. So northeast is halfway in between. Okay. So this is where the minute hand is facing. Now, through how many degrees does the minute hand move before it points northwest for the same time? Now, northeast is actually, you got 12. This 12 is here, and 3 is here. Northeast is halfway between 12 and 3. So there's 15 minutes here. So this is 7.5 minutes. Past 12. Okay. Now northwest is here, they're exactly the same thing, but it's on this side. Okay, so there's a 7.5 this way as well. So altogether there's 15 minutes. Now 15 minutes is a quarter of a circle. You see? Because 60 minutes is for a full hour, and it says how many degrees does a minute hand move? So it moves all the way up to that. Okay, this thing here is 7.5 minutes. To 12. And this is past 12. So you got 15 minutes in between. But 15 is a quarter, as I say. So this is 90 degrees. That angle. So it has moved through altogether it's 360. So it's 360 minus 90. Yeah, in clock problems, it's nice to know that 60 minutes represents 360 degrees. If this minute hand moves through 60 minutes, it's actually traveled a full circle, which is 360 degrees. So 1 minute is 6 degrees. It's very useful to know that 1 minute represents 60 degrees. So that's another way of looking at it. This 15 minutes and will represent, each minute represents 6 degrees. So 15 times 6 is actually 90. That's another way of seeing why this angle here is 90. Okay, so so you can see the answer is 270 degrees, and I get to this rather quickly. Let's go to problem number 9. It says here the ratio of the sizes of two complementary angles. Now, so what do you mean by complementary angles? The angles add up to 90 degrees. Two angles whose sum is 90 degrees are said to be complementary. And the ratio is 4:5. So divide in the ratio. Four is to 5. Okay, so how do you do that? The way to do this is 4:5. There are 9 parts here. This is 4 parts. This is 5 parts. So the 9 parts make 90 degrees, right? The whole thing is 90. They add up to 90 degrees. 4 plus 5. And 9 parts is 90 degrees. So one part is 10 degrees. So 4 parts. So the angles are 40 and 50. Okay, so you can see 40:50 is 4:5, and they add up to 90. The way to get the 40 is 4/9 times 90, and 5/9 times 90. 9 goes to 90, 10 times 10 plus 40. So that is how you work out these things. And the smaller angle is increased by 40. So the smaller angle is 40 degrees, is increased by 10%. Increased by 10%. Now, 10% of 40 is 4. 10% is 1/10. So you are adding 4 degrees to that. When you increase this by 10%, it's 1/10 of 40. So it goes up to 44 degrees. And they say, what must the percentage, by what percentage must the size of the larger angle be decreased? The larger angle is 50. The decrease, so the two angles remain complementary. So this new angle is 44. So to get the angles to remain as complementary, it has to be 44 and 46. If you reduce this by 4, if you increase this by 4, you have to decrease this by 4, so that the sum remains as 90. So now you want to know what percentage, and this is a decrease, it comes down by, well, we don't know, say X%. Okay, so what you have is X%, just as you had 10% of 40. So now you got X% of 50. You're decreasing by X%, and is actually 4, because the actual decrease is 4 degrees. So you can see the 50 cancels here. So you have X over 2 is equal to 4, and therefore X is 8%. So if you look at 8% of 50, that's 8 over 100 of 50 is 4. So this is a decrease by 4 to get to 46. Okay, the question is by what percentage was the size of the larger angle? So the answer is 8%. The larger angle has to be decreased by 8% so that the angles remain complementary. All right, so that takes care of problem number 9. So let's get on to the next problem, which is problem number 10. Oh, there it is. You got your 8% there. Oh, this is very, very small. Can I make this bigger? Hmm. Just hold on. Let me see whether I can make this thing bigger. Oh, I can't make this bigger. And this, I'm going to get out of the share. Sorry about this. Let me just stop the share and get to my thing. Hmm. Now what happened here? Still on. Hmm. Not allowing me to. Let's go up to 200. Hmm. Why? All right. I think I remember the question. So sorry about this. I made this thing very small. Hmm. There we go. Okay. Let's um, let's hope that we get back to our thing. Sure. Oh, this is another share. Oh, sorry. Okay. Um, Sorry about this. All right, I'm going to go back to my presentation, return to the meeting, and share from here, and go to my PowerPoint. Let's hope this thing works now. And share, and go to the annotate. And yeah, now it looks as if, so we are screen sharing. Okay, so problem number 10 says, Afiwe and Ben try to solve the equation ax squared plus bx plus c equals 0. Now, this is a quadratic equation, and by now, I'm sure you know how to solve a quadratic equation. You can solve a quadratic equation in two ways. You can either factorize it, or you can use the formula. All right, so let's just see what this question is. However, each made exactly one error in copying the equation. So when they were copying it, Afiva, he made an error. What was his error? The solutions of Afiva's equation were -2 and -3 over t, but her A was wrong. So instead of copying ax squared plus bx plus c, she made a mistake with the small a, and I'm going to put capital A to show that she wrote the wrong A. That's the only thing that was wrong. So she was using this equation here, and the roots for this equation are -2 and -3 over 2. All right, now by the solutions, so in other words, this is x minus 2 or x plus 2 into x plus 3 over 2. And when you make this equal to 0, you'll see the solutions are -2 and -3 over 2. So this is what the solutions she came to. But remember, this A will have to come out. So this A is in the front. This is A into, to make these two exactly the same, x times x is x squared, but here I've got ax squared. All right. So this is the equation that she was working with. And then what was he doing? He took his ax squared plus bx plus c, and the solutions of Ben's equation, he also made a mistake, were 2 and 3, but his value for b was wrong. So he was using this equation here, ax squared plus something else. Let's call it b, right? And like before, this is small a into, right, the small a, but the roots are, he's got 2 and 3. So it's x minus 2 into x minus 3. Okay. Now these are identically equal. This is exactly the same quadratic is here. So we can actually equate the coefficients. If I expand this, let me just do that, ax squared plus bx plus c, and let's just expand this, you get ax squared. Right, when you expand this, you get 2x plus 3 over 2x. So 2x plus 1.5 is 3.5. So it's 7x over 2. But remember, you have to multiply this by a. And it's a times, now 2 times 3 over 2 is 3. That's a constant. And you'll get 3a. Right? Okay, so you've got that these two are the same. So they're exactly the same. So a equals a, no problem. But what you have here is b, the small b, is equal to 7 over 2 times a. This is exactly the same equation, you see. So the coefficient of x will be 7a over 2 here. Coefficient of x is b, so they must be the same. And likewise, the constant term here is c, and the constant term here is 3a. So we are finding relationships between these symbols, a, small b, small c, and capital A, capital B. Okay, so that's the way to go for the time being. And in the same way, if I took this other equation, the second equation, I have here that ax squared plus capital Bx plus c, that there is equal to, now when you expand this, you get ax squared, small ax squared. And x minus 2 to x minus 3 is minus 2x, minus 3x is minus 5x. So it's minus 5, remember to multiply by a, minus 5ax. And -2 times -3 is 6. And a times 6 is 6a. So here you have a new set of equations, namely capital B is equal to negative 5a. Bx is equal to the coefficient of b, x on this side is b, coefficient of a is negative 5a. So that's what you got. And then you got your c is equal to 6a. The constant term here is c. And all right. So I need space. So let me just, or maybe, yeah, I need space. So let me just remove these guys. I've used them now. So I don't need them. I've got a number of equations, 4 equations here, which link the capital A and the capital B with small a, small b, small c. Now, what's the question? Determine the solutions of the correct equation and find the product of the two solutions. So what is the correct equation? The correct equation was ax squared plus bx plus c. All right, now let's see what this equation is. Now you see from here now, I got the 3 capital A is equal to C is also equal to 6A. C is equal to 3A and 6A at the same time. So immediately you can say capital A is 2A. Which means that small a is capital A over 2. B is equal to 7 over 2 A. Now you can see I want to get everything in terms of capital A. B is 7 over 2A. Can C be written in terms of A? Ah, yes, C is 3A. So now you got capital A right throughout, one symbol, okay, which is very nice. I've written everything, little a, little b, little c, in terms of capital A, because that allowed me, these equations allowed me to do that. So I can take capital A out. I'm going to take out the a over 2, because that's a common factor, into x squared. You take out a over 2 is plus 7x, and you take a over 2 is 6, right? Because this is 6 times a over 2. 3 is 6 times half. So now this is, I have my quadratic. See, this is my quadratic, which is equal to 0. And this means that the actual roots, because this can be factorized, it's x plus 1 into x plus 6. Right? You can try your various methods of factorizing a trinomial. This is what you'll get. So x is negative 1 and negative 6 are the real solutions. Because these are solutions for your original equation. See, on the left-hand side, I've got ax squared plus bx plus c, and I made it equal to 0. Right? So these are the correct solutions. We can say are the correct solutions. But the question says find the product. I always answer the question. The product of the two roots are negative 1 times negative 6, and that is 6. And they say product of the two solutions. These were the two solutions. The product is 6. So that's the answer to this problem. Product is 6. Let's just check to see whether this is the answer that we had. Oh, I don't think. Oh, there it is. Okay, so we have 2 pages of solutions. You can, if you didn't understand that, you can go back and rewind and try to fully understand this question. Okay, we go on to the problem 11. Problem 11, I've got no space to answer this question, but anyway, I'm not sure whether I need space. So listen very carefully. I'm not writing anything down. A padlock has a 4-digit code, right? So you know that what a padlock is, hopefully. It's like on a travel bag, you have a code. And why? Okay, sorry, I don't know. Let's take that out. Okay, so I'm going to put down those 4 digits. We have spaces for them, and we need to find out what these digits are. All right, now, one of the possibilities is 2657, but this has 2 correct digits, but neither are in the correct place, right? So we don't know which of these 2 are correct. These numbers are correct. 2 of them are correct, the numbers, but the numbers are in the wrong place. Now, if you look at the next one, he says 4268 has no correct digits. So 2 is wrong and 6 is wrong. I'm looking at 2 and 6 because that's where we are there. So this is wrong. That is not one of the digits. So amongst the digits, you got 5 and 7 are digits in the padlock. We don't know where they are though. Neither of them are in the correct place. All right. Now, the third, we finished with that. Now it says here that this thing has got only 1 correct digit, but it's in the wrong place. Well, we already know that 5 is a digit. Right? So it's referring to 5. That's the correct digit. But all the others are wrong. 0 is wrong. 4 is not in the... And those 3 are not correct. They are not in the correct answer. And this thing is in the wrong place. So this 5 is somewhere here, but this is not in the 4th place. 5 is not in the 4th place. So just bear that in mind. Now, the last piece of information says that 1749 has 2 correct digits, and both are in the correct place. Now, we saw that 1 is incorrect. Oh yeah, all these are incorrect. Right. So we saw that 1 and 4 are incorrect. There it is, 1 and 4. So these are incorrect. So 7 and 9 are in the, it's got 2 correct digits, but both of them are in the wrong place. So you've got 7 and 9, also 9. Right, so you got 3 digits. Now, where's the 4th one? We used up all the information here. So what is the 4th digit? Now, if you look at all this, you'll see that the numbers 1, 2, 3 is not here. 4, 5, 6, 7, 8, 9. All the numbers are represented here except 3. So nothing is said about 3. So therefore, 3 is also a digit. Right? So the digits, now we got the digits 5, 7, 9, and 3. And the question is the 4 digits in the key are all different. As you can see, 5. What is the sum of the digits in the code? So we need to work out the sum of these 4 digits. That's easy now. Because 5 plus 7 plus 9 plus 3 gives you 24. They didn't ask what the actual code was, but we can actually figure it out. The 7 and the 9 are in the correct place, it says here. So this is 7 and the 9, right? And we know that 5 is not here because both these are in the wrong place. So 5 is one of the digits. It's not here, so it has to be here. And then the fourth one will be. So this is the actual code, but they're not asking for that, but because they're asking for the sum of the digits. But you can actually work out what the number is in the code. Okay, so hopefully I've explained everything in the next one, but otherwise you can rewind and figure out what the logic was to come to the final answer. So there it is, 5739, and the whole explanation is given there. Okay, so let's go to problem number 12. Problem number 12 says calculate the value. Oops, we've got a huge calculation here. You got a fraction with a numerator looks like a massive figure because you have to multiply this. 3 times 4 times 5 is 60. And here you have to multiply these 3 and you get 480, 48 times 10. And you keep going on until you come to this huge number here and you add up all these numbers. Same thing with the bottom. And you're going to calculate this value. It looks as if it's impossible. But if you look carefully, you'll see here that 6, 8, 10 is really 2 times 3, 2 times 4, 2 times 5. It's 3, 4, 5. The same 3, 4, and 5 comes up, but the 2 can come out 3 times. If I take out 2 here and 2 here and 2 here, I'll have 2 cubed times 3 times 4 times 5. So let's just exploit that. I'm going to put this long denominator and this is, we'll leave the 3 times 4 times 5 intact. I want to put dots in between. 3.4.5 plus, yeah, I've got 2 times 2 times 2 comes out, or 2 cubed. Let's just leave it as 2 cubed. And this is 3 times 4 times 5. Again, the same thing happens here. This 3 times 3, 3 times 4, 3 times 5. So you have 3 cubed times 3 times 4 times 5. And plus all these things. And here you have 11 cubed. 11 times 3, 11 times 4, 11 times 5, times 3 times 4 times 5. The bottom, you've got 1 times 2 times 3. And again, as you saw before, 2 comes out 2 cubed into 1 times 2 times 3. And here you have 3 cubed, 1 times 2 times 3. So 3 times 1, 3 times 2, 3 times 3. all the way up to 11 cubed to 1 times 2 times 3. Now you see 3 times 4 times 5 is a common factor here, right throughout. So it's 3 times 4 times 5. I'm going to take it out as a common factor. So here it goes into 1 time. Here it goes into 2 cubed time. 2 cubed. And here is 3 cubed. All the way 11 cubed. And the denominator, in the denominator, you got 1 times 2 times 3 is a common factor. And the remaining factor is also 1 plus 2 cubed plus 3 cubed. All right, so you got a product at the top. There are 4 terms in the top. Understand that. 3 times 4 times 5 plus this big thing here. It's a single term. Right? If you add up all these things, you get a single number. And here you got 1 times 2 times 3 times this. So this single term here at the top it cancels with this thing here at the top. Everything is being multiplied here at the top. So you got 3 times 4 times 5. The 3 cancels. 2 goes into 4 2 times. Final answer is 2 times 5, which is 10. See, or if you want, you can multiply. It's not so difficult. 3 times 4 is 12. 12 5 is 60. 60 divided by 6 is 10. Okay, so that takes care of this problem number 12. So let's just check this out. And sorry. Okay, there it is. So you got this detailed calculation here, which gives you the answer to be 10.